or if this whole thing starts going bad, just sign out and we'll wrap up on Monday. Okay. So, all right. I left off yesterday. We didn't get through a lot because remember I had those technical difficulties. The circumference of a circle, and basically we kind of said that, you know, pi is equal to 180, right? And that's right here on the unit circle, and that's really important because that's how we convert between radians to degrees and degrees to radians. Okay. Now, eventually, some of them you just memorize. Like you should know that pi radians equals 180 degrees. Okay. You should know that 2 pi equals 360. Pi over 2 is 90. That's one you should know. If you're planning on taking calculus next year, you got to know that pi over 2 is 90. And then we know 3 pi over 2, which, by the way, someone asked yesterday, is 270. You could write it as 1.5 pi, but you'll never see it written that way. It'll always be written as a rational expression, so they'll write it as 3 over 2. Okay? 3 over 2 is 1.5. Remember, here was the justification. If 180 is pi and 360 is 2 pi, halfway between 180 and 360 is 270. Halfway between 1 and 2 is 1.5, right? Forget the pi, it's just 1. Look how you go around. 1, 1/2, 1, 1.5, 2. Then you just tack the pi's on for radians. Okay, so here's how we convert. And again, you may have seen this last year in Algebra 2, but again, it's worth reviewing, especially in the era of lockdowns and remote learning. So 125 degrees. First off, what quadrant is 125 degrees in? Who can tell me? What quadrant is that in? It's an easy one. Everyone go to quadrant 2? It's somewhere over here. Rough sketch, 125. Okay. All right. Well, if I want to convert it, here's what you do. You do 125 times pi over 180. Now remember, pi and 180 are the same, so it's essentially like you're multiplying by 1. Hold on, I got to pull up my calculator. That'll take a minute. Okay? It's essentially like you're multiplying by the number 1. Oops. Just give this a sec. So slow. Sorry, here we go. Okay, now, if you are using a graphing calculator, okay, one of the things I always tell kids is, what you end up with is 125 pi over 180, right? So what you're looking to reduce is 125 over 180. Now, you may know how to do that, or the nice thing is if you have an Inspire or graphing calculator, you can just type in, watch, 125 divided by 180, and get 25 over 36. See, that's nice. That's one of the nice things about an Inspire, okay? So let's write that as 25 pi over 36. Now, here's what I want to show you. So you're saying 125 is the same as 25 pi over 36. Okay. Now, 125, if you go around here, there's pi over 2 and pi. Sorry, and there we go. So 25 over 36 is less than 1 pi, right? It's between it's less than 1. So see how that makes sense? You're before 1 pi. Kind of makes sense. All right, 12 degrees. So if I did that, you do 12 times pi over 180. Okay. Now 12 degrees is a really small angle, right? In the first quadrant. Small, right? Little, 12. Okay. But again, now you could just reduce this. You guys know, or if you need to, you come over here. But if 1 over 15. So that would be 1 pi over 15. Now, isn't pi over 15 really little? Right? Sorry. See how that's really little? So you could make that, And the last one, negative 425. If you wanted to, you could do it times pi over 180. And then what happens is if you reduce these down, is you're going to have a negative angle, and that's okay. You get negative 85 over 36. So okay. Is everyone okay with converting from radians to degrees to radians, excuse me? Pretty simple, right? Now let's go radians to degrees. Okay. And like I said, you should know your way around, okay? You need to know your way around the circle, guys, in radians. So I know we always do degrees, but you should also eventually know this. Pi over 2, pi, 3 pi over 2, and 2 pi. Now, here's a question for you. Let's talk about 3 pi over 4 before we do it. Could anyone tell me? Ignore the pi. That's like 3/4, right? What quadrant would 3 pi over 4 be? It's a little less than 1. So what quadrant would you put it in? Again, take out the pi. It's 3/4. So look at how the pi's go around. Where do you think 3/4 pi would be? Everyone good with quadrant 2? It's got to be over here somewhere. So when I convert it, I better get an angle between what? 90 and 180? Okay? Remember, it goes 90, 180. So let's see here. Here's how you convert these. You're going to do times 180 over pi. Again, 180 and pi are the same thing. So when you multiply by pi over 180 or 180 over pi, you're not actually changing the value. Does that make sense? You're not changing the value. You're just rewriting. Now, with these, kids usually know it. The pi's usually cancel out. And so you end up with, I'll erase this over here. You end up with 3 times 180 divided by 4. So let's see what that is. And you probably don't even need a calculator, but 135. That's good, right? 135 would be a second quadrant angle. So we'll say 135. And there you put 135 right there. Okay, you guys try one. Try 11 pi over 12, and then we'll do the last one. Okay? So again, you just have to know when you're going radians to degrees, you want the pi's to cancel out. The pi's do go away here. Anyone have a degree on that? What do you guys think?
165.
Is it 165? Yep, good. Thanks, Deborah. Thanks, Sarah. 165. Good. And then if you have a negative, it's the same process. Pi's go away. Again, if you need a calculator, you would just say -5 times, oh. Doesn't like the negative button from the computer. See what I mean? -150. So you get -150, which again, you could make positive by adding 360 to it, right? And that comes out to be positive 210 if you want. But, or then you could convert that back, right? That'd be times pi over 180. And I'll show you different ways you can do this. And those that divide by 60, 30, 7 pi over 6. So if you want, you can always, like, you know, work your way back and around. Okay. All right. We're not going to do arc length, but I will say this. Here's let's review our 2 triangles. Let's draw them down here. We're not doing arc length and area. I thought we were going to, but it's not an MCC topic, so it's okay. We have a 45, 45, 90, right? And then we have a 30, 60, 90. These are the 2 triangles you need to know. Okay, let's start with the 45, 45, 90. What are the sides? First off, in both of these, what's the hypotenuse going to be, guys? What do you guys think? What's the hypotenuse going to be? Good. 1. Anyone want to tell me? Start with the 45, 45. Anyone want to tell me the sides of those triangles? Think 45, 45. So your sides need to be the same because the angles are the same, right?
That's 2 squared over 2.
Yeah, that's rationalized, I think, Taylor. I just have kids usually radical 2 over 2. If you rationalized it, Taylor, you'd be right. It'd be 2 radical. Well, no, that is right. It's radical. Or Taylor, you're right. Did you say 2 over radical 2? You could write it like that if you want, but I'd rather you just write it as radical 2 over 2. Okay? And then in this one, opposite 30 is what? What's always across from the 30? Good, Deborah. Thank you. A half. So opposite 60 is always radical 3 over 2. And remember, these were the 2 triangles that we had to know. Okay? So now if I said do the cosine of pi over 3, eventually, my hope for you in life, well, I want you all to have good lives, but that starts with doing well with trigonometry and pre-calc. I hate to break it to you. Okay? But eventually, I'd love for you to know that pi over 3 is right here is 60 degrees. See why this chart's so nice and handy? Pi over 3 is 60. But if you don't know that, what you do is you say, okay, well, I would come over here. I'd say pi over 3 times 180 over pi, right? Do your little conversion, and you get 60. So for a little while, you might actually come by and do those conversions. Okay, so instead of saying cosine pi over 3, do the cosine of 60. It's okay if you write it like that. Is everyone okay with that? Okay, cosine of 60 is adjacent over hypotenuse. So that would be 1/2 over 1, or just 1/2. You guys good with that? Okay. How about the sine of pi over 6? Okay. Well, first off, if pi over 3 is 60, what do you think pi over 6 is? And again, we could do it by converting, but anyone know what pi over 6 is? Pi over 6 is 30. Yeah, thank you guys. Because if you do the 180 over pi, you get 30 degrees. Sine of 30 is opposite over hypotenuse from 30, opposite over hypotenuse, so that would be a 1/2 as well. Okay. And last, tangent of pi over 4. This one you should probably just know. But again, we can do the conversion, but what do you think pi over 4 is? Good to guess.
Oh, 45.
Kids are being quiet. You get
45. I thought I said that already.
You did, Sarah. Thank you. I appreciate it. 45. Okay. Tangent of 45 is opposite over adjacent. So you get radical 2 over 2 over radical 2 over 2, which ends up just equaling 1. Okay. Now, obviously, if you're on the graphing calculator, you can type these in easily. You have to make sure you are being careful of what mode your calculator is set to. Everyone here is good with understanding mode, right? Okay. Now, for those of you that have to go on in life and take more math, you might as well just get used to having your calculator in radian mode. Okay. So if you have a graphing calculator, you want it in radian mode. I tell my calculus kids they should never be in degree mode anymore, which seems weird, but like, you know, so when you go tan, because watch, if you're in radian, you don't even have to change anything. You can do tan of, hit the pi button, it'll do it, pi over 4, it'll say 1. Okay, so get used to being in radian mode. Okay. We're going to skip some of these a little bit. I'm not going to do area. So what if I asked you to do, for example, how about something like this? Are you guys okay if I just add problems here? What if I said, let's do the cosine of 2 pi over 3? Okay, now, everyone with me? All right. What do you think most kids would probably do first there? What would you guess? What do you think?
Change
What do you
it to
think?
degree.
Change it to degrees. Yeah, so most kids would probably convert that to degrees. So you're going to say, okay, 2 pi over 3 times 180 over pi. Those go away, right? And I think you end up with 120. Now, here's what I tell kids. You can do the problem in degrees if you want, okay? So here's what I'd like you to do. Draw a little sketch of 120. Think about where 120 is. It's in the second quadrant. See if you can figure out the reference angle, okay? And then label your sides, okay? So figure out the reference angle. This is all review. Trigonometry, guys, is one of those things where everything kind of ties together at the end, okay? So it's very like sequential, and by the end you have to like, you know, so. Oops, sorry. Okay, can anyone tell me the reference angle? You guys forgot? Reference angle is always this little guy in here from the bow tie, guys. Nothing changed. It's how far you are from the horizontal. So it's 60. Good. It's 60. Everyone good with 60? So then you have a 30, 60, 90. So across from 30 is a half. Across from 60 is root 3 over 2. And hypotenuse is 1. Do any of those sides get negative signs? Do any of those get negative signs? Yes, Aiden, what side? Aiden, oh my, Aiden H, right?
The one on the x-axis, the half.
There you go, bud. Good, thank you. And Aiden, so we got a half. Okay, question said cosine. Now, again, everything ties together. Before you start the problem, let's think about this. I'm in the second quadrant, and I'm doing cosine. All-star trig class, or all students take calculus. Should my answer be positive or negative? I'm doing cosine in the second quadrant.
Negative.
Negative. Guys, come on. I'm really trying to have a good day with my new chair. I need you guys like participate and stuff. This is like a big day for me. I'm not going to lie to you. Okay. We don't. So negative. So the cosine would be adjacent over hypotenuse, negative 1/2 over 1, or you just say negative 1/2. Okay. Is everyone okay with that? Now, what if now this is an MCC thing. MCC kids, perk up. If I said, tell me what the reference angle is, you can do the work in you can do the work in degrees, but if you write 60 degrees, I would have to take a point off. You see how the problem was presented in radians? You answer in radians. So 60 degrees, you'd have to convert back to radians at the end. Is that, you guys okay with that? Times pi over 180, and that is pi over 3. So the reference angle is pi over 3 technically. Is everyone okay with that? Okay, I don't want you guys like being too confused. Okay, let's try another one. I'll give you guys a chance to practice. Hold on, let me see. Where'd my other thing go? It's having some tech issues. Not that. Oh, I know a good one. You guys are like, you guys must just like hate this. I don't know, maybe you don't. Let's do the, hold on, here we're gonna cross this guy out. The cosine of negative 5 pi over 6. So now, if you want, what I would suggest maybe is converting that to degrees at first, or make it positive, okay? Then I'll show you how you can make things positive too. So make it in degrees first, okay? Go ahead and work on that. By the way, do I have Taylor Sheldon? Carson, are you here? Is Carson in? No. Uh, why does that? Oh, here it is. Jeez, what is wrong with me today? Oh my gosh. You guys are almost to break. You are almost there. Come on, guys. You can do it. You can make it. Okay. First off, did anyone get that to convert to a degree? Yeah? What'd you guys get when you converted that to a degree? Oh my God. A degree. Struggling with life today, guys. Yeah, good. Negative 150. Okay. So if I want to add 360 to it, is everyone good with 210? Yeah? Now, if you guys wanted to, if let's say you really liked radians and you wanted to practice fraction math, what could you add to negative 5 pi over 6? Instead of adding 360, what could you add to it to put it in radians? What's like adding 360 in radians? Come on, guys. What's like adding 360?
2 pi.
2 pi, right? So couldn't you add 2 pi? Watch. And then if you do your common denominator math, 6 and 6, so that's like 12 pi. Negative 5 pi plus 12 pi is 7 pi over 6. So 210 is the same as 7 pi over 6. Some kids like to do it all in degrees and then convert it back to radians at the end. Okay? Anyway, 210 is in the third quadrant. It's down here. So I'm going to draw my bow tie in the third quadrant. Why did I write 180 there? Oh my God, what is wrong with me? 360. Okay, who can tell me what the reference angle is? What's the reference angle for 210? And remember, guys, reference angles are always these little guys coming off the horizontal. So what's that reference angle going to be? Everyone want to say it at once? Taylor Ford, thank you. Thank you, Aiden. Thank you, Deborah. 30. So again, you have your 30, 60, 90 triangle. Okay, hypotenuse is 1. Opposite 30 is a half. Opposite 60 is root 3 over 2. Guys good with that? I went left and down, though. Look, negative, negative, left and down. The question said do cosine. Again, I'm in the third quadrant. What function is positive in the third quadrant? Or, you know, should cosine be positive or negative? How about that? What do you guys think?
Cosine should be negative.
Yeah, thank you, Adriana. Cosine should be negative. So if I'm doing adjacent over hypotenuse, I'm going to have negative radical 3 over 2 over 1. And there's my answer. You don't even have to put the over 1, but I got a negative answer, so that's good. Now, I'm going to assume most of you, when you do these, are going to probably convert the radians to degrees, right? But you didn't. If you were really a radian fan, and again, I'll come back to this. This is where this little chart comes into play. There's all your radians and the degrees. I would know. I've told kids before, if you can at least know the degrees and radians conversions for these, that's all you really have to know. I don't know off the top of my head like 8 pi over 9. Okay, but I know these. Okay, all right. We're going to skip ahead a little bit now. And we'll do We'll do one of each of these and then we'll call it a day. All right, number 7 here. Do you guys see this problem here? I can zoom in. Okay, it says find the exact 6 values of the 6 trig functions if the terminal side of theta contains a point. All this means is when they tell you stuff is you better plot the point. So write this down. You better plot the point and then draw your reference triangle, okay? You always go back to those reference triangles. So these are for angles that are not the common one. Okay. -3, 7 is over here somewhere. Okay. Plop down, plop down. -3, 7. Now, everyone good to there? Okay, what side am I missing? And it's not one of your common right triangles. So what side am I missing, guys? I'm missing the what? Come on. Hypotenuse? And how do you think you're going to find the hypotenuse? What are you going to do? Pythagorean theorem. Yes, guys. Listen. I give you credit for logging on, but let's you know, we're doing the best we can here, but we gotta like, no, whatever. You get it. I think you get it. You just gotta start understanding that this is what you have to do. So C equals radical 58. Newsflash, I don't want you writing it as a decimal. I want you leaving it as a radical, okay? That's basic Pythagorean theorem. Is everyone okay with that? All right, and then what I want you to do is find the 6 trig functions. So we're going to do sine, cosine, tangent. Now, those are your main 3, right? And then the others, we just know we flip them over. So we don't even have to find them because we're just going to flip fractions over. Okay, what's the sine of theta going to be? Oh, by the way, just remember, same as before. Your reference angle is always that little guy coming right off of there. The reference angle is always the little angle coming off of the horizontal. All right, sine, opposite over hypotenuse. Remember, you're in the second quadrant, so sine better be positive. Thank you, Sean. 7 over radical 58. Good. How about cosine? Someone else want to do cosine? Oh, anyone? I think you're muted, Sarah, if you were trying to talk. Go ahead, Sarah. Oh.
-3 over square root 58.
Thank you. Yep. Okay. And that's good. Look, we got sine positive, cosine negative, second quadrant. Then last, how about tangent? Anyone want to do tangent?
7 divided by -3.
Yep. And you can put the negative wherever. There you go. Perfect. Is everyone okay with those 3? Because now your other ones, you just flip them over. Cosecant is 1 over sine, so I would just write radical 58 over 7. Sine, I would just write negative radical 58 over 3. And cotangent, I would write 3 over -7. So you see, when they say find all 6, you're really only finding 3 and then flipping them. Does that make sense? Okay, we're going to do one more problem and then we'll do something else. But you guys think you could do one of those if I give you a point? The other way is a little trickier. Not really. Here, let's challenge ourselves. Number 10. And then we'll do some of these next week as like a warm-up. Let's look at number 10. Okay. Find the exact values of the 6 trig functions. Tangent theta is radical 11 over 5. And secant theta is, this should say less than 0. Sorry, that's a typo. Okay. Now, we got to think for a minute. All-star trig class. The angle they are giving you, it says tangent is radical 11 over 5. Tangent is positive. Secant, which is 1 over cosine, is negative. All that does is it tells you what quadrant to draw your picture in. What quadrant do you think I'm going to draw this picture in? You got tan positive, but cosine essentially, secant negative. Sean says quadrant 3. Is he right? Got to be in quadrant 3, right? Got to be in, so plop your reference triangle down in quadrant 3. It's the only one that would work, right? That's the only place you can have tangent positive and something else negative. Now, it tells you tangent is radical 11 over 5. Okay, tangent is opposite over adjacent. Everyone agree? So from your reference angle, which always goes right here, opposite is radical 11 and adjacent is 5. Now, what you have to be careful of is like what we did earlier. Do I need negative signs in those? Which ones get negatives, or do both? Both, right? Because you went left and down. Okay, negative, negative. So you see how I took the information to draw a picture? Now you do Pythagorean theorem. Just for time's sake, that is 11 plus 25. It's a square. Oh, it's 6. Yeah, right? Negative radical 11 squared plus negative 5 squared equals c squared. That's 11 plus 25 c squared. That's 36. Oh, so it's 6. Okay, so that worked out nice. Okay, can hypotenuse ever be negative? What do you think? No. Remember, no. Okay, so now let's do sine, cosine. By the way, in your test, they're not going to ask you for all 6. They usually only ask you for like 1. After this, we're done, guys. Anyone want to tell me the sine of theta from the picture? Remember, theta is your reference angle. Oh, oops. Anyone want to tell me sine? What do you guys think? Radical 11 over, yep, Sean. Yeah, you just, yep, negative radical 11 over 6. So we'll write it like that. How about cosine? Anyone want to tell me cosine? Cosine is adjacent over hypotenuse. Do I have someone else? Thank you, Sean. Good, yep. Adjacent, negative 5 over 6. Now look, sine and cosine were both negatives. That's good. Tangent, we already knew. Radical 11 over 5. Okay? And then you just flip them over. Oh. 5 over radical 11. 6 over negative radical 11. And negative 6 over 5. So I think what's going to happen, guys, like on a test or something, I'll just ask you for like one of them, you know. So. Okay. How's that? That good? Any questions? Everyone's blah today. Smile, kids. All right, you ready for? Did I ask you the question of the day about the Wi-Fi names? Okay, here's a fun one.